Hi, I'm Chris. This problem was given in a math Olympiad for 7th graders in December 2024, so not too long ago. We're given a square where the sides have been divided as in the figure, and they ask us to calculate the blue area. Can you figure out how to solve it? To make things easier, let's label the square as ABCD and the points of interest on the diagram. With these labels, the goal becomes finding the area of ECGF, the blue region. As the nerves are tense and the time is scarce during a contest, you might try and go by the first instinct to calculate the blue area as the sum of the triangles ECF and CFG. While that's totally possible, it gets tricky since these aren't right-angled triangles. Instead, there's a clever shortcut. Subtract areas of simpler shapes from the total square. Can you see it now? The trick here is to calculate the blue area in the following way. From the total area ABCD, subtract the area of DCE, the area of CBG, and the area of EFGA. Let's first calculate the area of ABCD, which is a square. The area of a square is essentially the length of one side multiplied by itself, so we take DC. DC is dn plus nc, which is 4x. So we get 4x multiplied by 4x, which gives us the area of ABCD as 16x squared. And we plug it back in the initial calculation. Moving forward, we take now the next area, which is the area of the triangle DCE. Because DCE is the right triangle in D, we can calculate the area as the height of the triangle multiplied by the base divided by 2. And in our case, it becomes DE multiplied by DC divided by 2. DE has the length of x, DC of 4x. And when we do the calculation, it becomes 2x squared. We plug it back in the initial calculation. Next, we take the next area, which is the area of the triangle CBG. Calculating this area is done in the same way as for the triangle DCE. Triangle CBG is a right triangle in B, and we can calculate the area of the height of the triangle multiplied by the base divided by 2. And in our case, it becomes BG multiplied by BC divided by 2. BG has the length of x, BC the length of 4x. And when we do the calculation, it becomes 2x squared. We plug it back in the initial calculation. We are now left with the calculation of the last area, which is the area of the square EFGA. Calculating the area of the square is essentially the length of one side multiplied by itself. So we take EF. EF is 3x, so we get 3x multiplied by 3x, which gives us the area of EFGA as 9x squared. And we plug it back in the initial calculation. And now we can calculate the area of ECGF, which is 16x squared minus 2x squared minus 2x squared minus 9x squared, which gives us 3x squared. So the blue area is 3x squared. If you like this video, drop it a like before you go and make sure you subscribe for more. See you soon for the next one.